Hey everybody, today we're doing the 0 times infinity indeterminate form using L'Hopital's rule. Here we're talking about limits where we have a product and one factor is going to 0 and the other is growing without bound. For shorthand, we say that's a 0 times infinity indeterminate form. This limit could be 0, could be infinity, could be anything in between. We need to do some more work to figure out what that limit is. Here's 3 problems. We're going to do all 3 of these. In each case, one of the factors goes to 0 and the other to infinity. The strategy is always the same. You're going to want to put one of those factors in a denominator, making an exponent negative. Then you have a 0 over 0 or infinity over infinity form, and you can apply L'Hopital's rule. Example 1. Limit as x goes to infinity, x e to the negative x. So the e to the negative x is literally 1 over e to the x. So let's just write it that way. And immediately we have a situation where we can apply L'Hopital's rule, infinity over infinity. Differentiate the top, differentiate the bottom, and we get 1 over e to the x. As x goes to infinity, that goes to 0. Example 2. Limit as x goes to 0 from the right, x squared ln x. X going to 0 from the right because the domain of the natural log is only positive numbers. So natural log of x is going to negative infinity, and of course x squared is going to 0, so this really is a 0 times infinity form. One of those factors needs to go in a denominator. There's no hard and fast rule about which factor to put in the denominator. You should always start by trying the easier of the 2 factors. So in this case, the x squared. We'll put it in the denominator, make it x to the negative second. If this doesn't work out, we'll need to go back and do the other factor in a denominator instead. Now I have an infinity over infinity form. I differentiate the top, I differentiate the bottom, and I get x to the negative first over negative 2x to the negative third. As x goes to 0, this is once again an infinity over infinity form. Before I charge in and do L'Hopital's rule again, though, I should notice that this can be simplified. The x to the negative third in the denominator, I'll put in the numerator as x to the positive third. Reduce the powers using exponent rules to get negative x squared over 2. And as x goes to 0, of course, this just goes to 0. Example 3. Limit as x goes to infinity, x sine 1 over x. So let's move the simpler factor, x, into a denominator, make it a 1 over x, or x to the negative first. And notice that we have an infinity over infinity form. A 0 over 0 form. The 1 over x is going to 0 in each case. L'Hopital's rule, differentiate the top, differentiate the bottom. On the top, I'm using a chain rule, differentiating sine to get cosine, differentiating 1 over x to get negative x to the negative second. Canceling the negative x squareds, I have the limit as x goes to infinity, cosine 1 over x. Now, as x goes to infinity, 1 over x goes to 0, and the cosine of 0 is just 1. And that's my final answer.